Hi everyone, my name is Vishal Bakshi and I'm an organizer with PyDataPDX. In this video, I'm going to walk through the Pandas 103 Lunch and Learn, where you'll learn how to perform data aggregation and group operations using pandas. The dataset we're going to use comes from the Ask a Manager salary survey, which at the time of this video contained about 27,000 responses from people across the world. Follow us on Twitter at PyDataPDX and DM us there to join our Slack. You can find all Lunch and Learn materials in the GitHub repo linked in the video description below. As always, I'll import pandas as PD and NumPy as NP. The first thing I'm going to do is load the data into a data frame and take a look at the first 5 rows. The first thing I'm going to do is load the data into a data frame and take a look at the first 5 rows. Each row represents one response to the survey. There's a timestamp, age group, industry, job title, annual salary, and many other fields collected in the survey. Let's take a look at the column names, which come directly from the Google form used as the survey. I want to rename some of these columns so that they are easier to reference in my code. To do that, I'm first going to create a dictionary which maps from the original column name to a new one. For example, instead of the name "How old are you?", I'll name that column "Age". I'll save the old column index for future reference in case I need it. I can rename the data frame columns by calling the method rename and passing the dictionary as the argument for the columns parameter. This will return a new data frame which I will assign to my original data variable. I also want to convert all names to lowercase, so I'll call the rename method and pass the str.lower function as the argument to the columns parameter. The return data frame is reassigned to data. Now, my column names are a bit easier to use. I'll take a look at how many missing values there are in this data set. I do that by calling the isNull DataFrame method and then calling the sum DataFrame method. This gives me a series object where the labels are the column names and the values are the count of missing values. The most missing values are in the other currency, income context, and job context fields, which are not the main fields of interest for this lunch and learn. There are also about 4,700 responses that do not have a state listed, but that makes sense given that this dataset received international responses. What are the data types of the values in each column? I can view them by printing the dtypes attribute of the data frame. What stands out is that the salary field is not of numeric type. It's probably a string, since integers or floats in Python are not displayed with a comma. I'm going to re-import the data in order to correctly parse the salary column. I'll save the lowercase names for reuse. When I read the CSV into a data frame this time, I'm going to pass the raw string comma character as the argument to the thousands parameter, and the lowercase underscore names index as the argument to the names parameter. Since I'm passing names, I'll set the header to 0, indicating that the header in the 0th row is to be replaced. If I look at the dtypes attribute now, I see that salary is an integer. Another issue with this data set is that it has mixed currencies. There are 11 unique currencies for the salaries reported. I'll convert them all to USD so that I can perform calculations on the entire salary column. I'll create a dictionary which maps currency to conversion factor. Then I'll create a new column called salary underscore USD, which will contain the US dollar equivalent of the salary values. The way I'm going to calculate this is by using the apply DataFrame method. Apply allows you to apply a function to each row or column of the data frame. Instead of doing element by element computations using a loop, apply utilizes broadcasting, which is a way to vectorize calculations to make them more efficient. You can learn more about broadcasting in the Pandas 101 video. So, based on the currency, I want to multiply a conversion factor with the salary value to calculate the US dollar equivalent. The apply method iterates over each row if you set axis equals 1, and over each column if axis equals 0. This takes the currency column, passes each value to the dictionary to get the conversion factor, and multiplies by the salary value. I'll illustrate with a trivial example. Here's a data frame with two columns, A and B, with 3 rows, 0, 1, and 2. Apply takes any function, so I pass it the print function. When I specify axis equals 0, it prints each column with access to row labels 0, 1, and 2. When I specify axis equals 1, it prints each row with access to column labels A and B. I specified a lambda function here, but I can also write a named function and use it. This function will receive each row as the argument. I'll pass the value of the currency column from that row to my currency map and multiply it by the value of the salary column from that row. That product gets returned. And again, I specify axis equals 1 because I want to access the column labels. So up here, I created this new column, salary USD. I'm going to make sure it's correctly created by looking at the first 5 rows. 54,600 pounds gets converted to 76,986 US dollars. One of the currency values was other, and these were not converted to a numeric value. Instead, I assigned them the NumPy not a number value. There are 133 such records that will not be included in my US dollar calculations. At this point, my data is clean enough for what we are trying to achieve in this Lunch and Learn. This leads to the question, what are we trying to achieve in this video? The types of questions we will not explore today are those which conclude correlation or causation. The types of questions that we will explore are how to use pandas to aggregate data to assist analysis. The protagonist of this Lunch and Learn is the GroupBy method. The GroupBy method splits the data, applies a function, combines the results, and returns a DataFrame GroupBy object that contains information about the groups on which group operations can be performed. Let's say I wanted to know how many survey responses there were for each industry. I first group the data by the industry column and then call the count aggregate function on the timestamp column. What's returned is a series object with industry names as the labels and corresponding timestamp counts as the values. There are 1,148 unique industries in this dataset. What were the most common industries in the survey? Here, I'll chain the command n_largest on the count series object. n_largest returns the first n rows in descending order. If I call n_largest on a data frame, I can also provide the columns by which to order the output. To reduce the number of unique industries in the dataset, I'm going to lowercase all strings and remove white spaces in the industry column and store them in a new industry underscore lowercase column. I use the apply method on the industry column, strip white space from each value, and then convert to lowercase. This reduces the number of unique industries from 1,148 to 953. How many responses are included in the top 10 industries now? I group the data frame by industry underscore lowercase, access the timestamp column count, get the 10 largest counts, and take their sum, which is 18,640 responses out of the 27,000 or so total responses. You can also calculate multiple group operations on multiple columns by passing a list of columns to GroupBy and a list of aggregate functions to the .agg method. Here, I'm grouping the data by gender and total experience, and then on the salary USD column, applying the count, mean, variance, and standard deviation aggregate functions. Note that in addition to these built-in functions, I can define my own aggregate function as well. You'll notice that the total experience groups are labeled in a way that doesn't order them correctly by default. It goes from 1 year or less to 11 to 20 years, then 2 to 4 years, then 21 to 30 years, and so on, because it's ordered by the first character. I can change these using the map series method. The map method replaces values of the series according to the input mapping provided. The keys of total underscore exp underscore map are the existing values of the series, and when passed to the dictionary, will return the new values that I want to use. Now, when I run the same aggregate functions on the same groups, by default, total underscore exp is correctly ordered. I can call n_largest after the aggregate functions and specify that I want the 10 largest count values listed in descending order. The greatest number of survey responses, 6,986, were from people who identified as women with 11 to 20 years of experience. Next, we're going to achieve a similar result using a different approach, which is something you'll see a lot of when using pandas, as well put by these tweets. I'll create what's called a pivot table using the pivot underscore table DataFrame method. The first argument assigned to the values parameter is the DataFrame column that I want to aggregate. The index parameter is assigned the keys to group by on the pivot table index. By default, the aggregate function used is mean. I can specify other functions by assigning them to the ag_func parameter. The last way we'll structure this data is in a cross-tabulation. The pandas.crosstab method first takes the values to group by in the rows as the index parameter, and the values to group by in the columns as the columns parameter. By default, margins is false. When passed true as its argument, the totals of each column and row will be calculated and displayed with the key all. The default aggregate function used is count. So here we see that there are 22 responses from people who identify as non-binary and have 0 to 1 year of experience. I can pass a different aggregate function, such as mean, if I specify explicitly the values that I want to aggregate. In this case, the salary USD column. The last point I want to address is the format and structure of the race column. There are 48 unique responses to the question, what is your race? Choose all that apply. But are there really 48 unique options? No. The survey allowed multiple answers using checkboxes. If someone selects more than one checkbox, Google Forms concatenates the strings into a single string value. For example, the second survey response came from someone who selected the checkboxes for Hispanic, Latino, or Spanish origin, which is one checkbox, and white, which is another checkbox. If I want to see aggregate data grouped by single race values, I can't use the group by method since it will group the data based on those 48 possibly concatenated string responses. Instead, I'll take an approach of creating a Boolean column for each unique race checkbox value. I'll start by creating a new column for each of the 7 race values in the survey. If the existing race column contains the race value, the value in that row will be true. Otherwise, it will be false. I run that cell and see that 7 new columns have been created in the data frame. I'll take a look at the original race column and the 7 new columns next. In row 12, there are 2 race responses concatenated, Asian or Asian American and white. Therefore, the Asian or Asian American and white columns have a true value, whereas the others are false. How do we handle data aggregation for all of these columns so that aggregate data for all races can be observed in one data frame? One way to do that is to calculate aggregate data for each race and then combine them into a single data. For example, if I wanted to view the average salary in US dollars by race, I could do something like this. First, create an empty data frame within which we'll eventually populate this aggregate data. Next, I'll loop through each race string in my list of races. For each race, I'll create a mask, which is a series of Boolean values where the values in that races column are true. I'll pass that mask to the full data frame in order to select only those rows where that particular race is true and apply the aggregate function to the salary USD column. The value returned is stored in the data frame. I can put this into a function which I'll call group by race. This function takes the full data frame data, a list of column names, races, the column name to aggregate, column, and the aggregate functions to apply to that series, agfunc, which by default is the mean. I use the same lines of code I did before, except I return the transpose of the data frame so that the race names are the row index. I then call that function, specifying multiple aggregate functions, and receive a data frame in return. What if I wanted to group by race and other indexes? I'll utilize the pandas.concat function here. For example, suppose I had one data frame, df1, showing the count and mean for salary USD, grouped by gender for people who identified as Black or African American, and another data frame, df2, showing the count and mean for salary USD, grouped by gender for people who identified as Asian or Asian American. I can combine these two data frames by wrapping them in a list and passing them to the pandas.concat method as the first argument, and passing a list of the two race strings as the argument to the keys parameter. I'll implement this into the GroupByRace function I created. I'll add a parameter by, which will be used as the argument to the DataFrame.groupby method. If an argument is assigned to the by parameter, a list of data frames where the aggregate value is calculated on the specified column of each race's data frame grouped by the argument. I'll call GroupByRace again, passing the argument gender to the by parameter. What I see in return is a data frame with a multi-index for the rows. Finally, I'd like to be able to create a cross-tabulation using the unique race columns. First, I'll group Black or African American responses by gender and apply the mean on the salary USD column. This returns a series with gender labels and mean values. I'll do the same thing for Middle Eastern or North African survey respondents. Next, I'll create a dictionary with race string keys and series values and pass it as the argument to the data parameter when creating a new data frame. The result is similar to the output to the pandas.crosstab method. I'll add a crosstab parameter to the GroupByRace function. If an argument is passed to it, the aggregate function is applied to the given column on the data frame grouped by the by parameter for each race's data frame and added to the new data frame under that race's column. I'll check to see if that crosstab parameter works as expected. And it does. I can now see the mean salary USD for all pairs of race and gender. That brings us to the end of this Lunch and Learn. Please take a look through the references at the bottom if you would like to see either where this data comes from or more examples about the Pandas API. Thanks for watching.